Right, audio check. 1, 2, 3. Sounds okay to me, so I guess we can get started. Ladies and gentlemen, welcome to the stream of the Discourager of Hesitancy. We are building a game with no game engine, and we are in the final stretch. This is always the joke, right? I'm 90% of the way done. All that's left is the other 90%. We're kind of going through a polish phase, right? Where I'm going through each part of the game and trying to clean it up, make it better, fix issues, and just make it look and play smoother. So we've got music we can do. We've got to upgrade some mediocre programmer art on a couple of items. Or no, upgrade from crappy developer programmer art to mediocre programmer art. Once all the art's in, then we've got to get some better art. That'll probably be done off stream. Nobody wants to sit around and watch me not art well. And then I would like to add some doodads and such for people to click on and interact with that have nothing to do with the game. That's always very satisfying. It's one of the things I really liked about Hearthstone was clicking on the environment. Especially once they took away Oil Blade Flurry. That made me sad. I didn't play much longer after that. I played for a while, but when the only thing you can really do as a rogue is play random card generation or zoo, I like the tempo deck, and the Blade Flurry and Oil was really the only way to keep pace with other shenanigans. So anyway, that's besides the point. The point was that those environments were excellent. If I was a great artist, I would also try to make a great environment. So we'll settle for a programmer environment on this game since I'm doing this one solo. Today I'm going to be a little bit interrupted. Probably have to take off in about 2.5 hours or so. Maybe a little bit earlier than that, 5 or 10 minutes before that. So I got to help some lady do some stuff. She got to move some things around. And then depending on how long that takes, because that's some, I don't know, almost 30 miles away. And I don't know how much moving there needs to be done. So I may pop back on stream for an hour or two in the afternoon after I get back, or maybe not. It depends. Which means today was interrupted and or short. So I don't want to actually tackle anything too serious today with the interruption at 3. So right now I'm leaning towards continuing where we left off yesterday with generating music given just our tonal waveform generation. We stubbed out a quick prototype the last hour yesterday. So that's this one. We're going to play with it a bit more and see if I can make anything sound okay. If we end up not liking where we end up with this at some point, like if I feel it's worth abandoning, we may just go to like Pixabay and find a whole bunch of royalty-free music. Yeah, we've rapidly prototyped a thing for generating waveforms in this song. I don't know if I want to do this, or if we do this, it means I can use a lot of classical music. We can do the old Ode to Joy. We can use pieces out of the Nutcracker Suite, or Bach, Beethoven, Mozart, all the dead ones, Tchaikovsky, Peter Ilyich Tchaikovsky. Yeah, you have lots of options there. I had 2 older sisters when I was growing up, and they were both piano performance majors. So I listened to hours and hours of classical music every day being played on the piano. They'd get home from college, and each of them had to practice about 3 hours a day. Scales, classical music, good stuff. So maybe we'll do that. Maybe we'll just steal dead people's music and run it through our waveform generator. Then I don't have to credit anybody. I mean, I'll still put the list in the about somewhere. But I can also pack an awful lot more audio if it's waveform generated. So, for example, let's go into our song class that we stubbed out. Each of these instructions is 1 byte. So to play, 2 notes, this is, a small handful of bytes. We can actually do some crazy cool things. Like, we're basically creating a Turing machine for music out of this. Is that something I want to do? Do I want memory? Oh, we can have some memory in. I mean, this is so bad for my scoping of the project. Like, ideally, I would have, a couple dozen songs, slap them all in, random generate, done, right? What I'm contemplating right now is a Turing machine to play music, which is really kind of a fun project. Fun project, but is that good? Like I said, I can pack a lot more data this way. If I can make it sound good, maybe it's worth it. Unsure. Yeah, I don't know. We're just gonna play with this today. That's all. We're gonna explore. We're just gonna play. I part of me kind of wants to build the music as a Turing machine. Probably not a. Okay, maybe not a Turing machine. Not in the sense of a von Neumann virtual machine architecture, but I'm thinking like a Harvard architecture. Yeah, this could be fun. Oh. How badly do I want it? Okay, so let's line up our tasks for today. We need to have some clearly defined tasks, even if we're sort of faffing about oh, good heavens. Why is everything expanded out? I just want this day. There we go. Okay. So all of this is song related. Song tone is off. Probably an index error. Need to handle different data sizes in song instructions args. Song needs BPM. Song abstractions. Play note rest in fractions of beats. And so far none of this is making the tone itself sound better. That's a maybe we'll do that tomorrow. Tomorrow is also kind of an interrupted day or a short day. We want to play a C major scale. We want to play a few bars of Ode to Joy. And the ideas here are endless. We could do song. This is all the song class. Play chords. Each note has its own timer. Turn off. So a pool of notes. Each note has its own timer to stop. Another thing we might want. What else? Another thing we might want to do are things like go to, jump, store value, change instruction, more virtual machine-like operations. Basic math. Branch. Yeah, there's a lot of this. And then another thing we want to do on songs, make the tones sound better. So first here are just minor improvements to bring us up to a thing. Okay, let's just see how far we get today, and like I said, maybe tomorrow as well. We'll screw around with this song thing. It's very interrupted streaming this week. Short sessions. I feel like this is probably a good starting point. So, and if we at any point we're like, this is not worth it, then we'll bail. We don't have to keep going. It sounds like a fun project, but it needs to sound good. So I'll be back in a minute and use the restroom. Okay. So I think we have things to try today. Okay. All right, let's just take this for a test drive. We got to figure out why our tone is off. So if we go to sandbox, this is C4, so the C starting the fourth octave. And if we start the song, that should be C4. So that first one is not the same. So I think we just have an index error somewhere in song. So everywhere this O. Okay, so let's talk about this real quick. Sound defines by name every note. Now, a D sharp is the same as an E flat. They're the same frequency, but I want to be able to use either name. So we double define it. So in tone, so let's see here, because of the way that notes are defined, they're specified in this order, which has a chunk of the 0th octave here, defined for some reason after C8. Probably, well, so it's because of extended pianos, right? So standard piano is basically going to end here, and an extended piano is going to have more on the bass range. So that's basically tacked on the front of this list, and then it's also going to have more at the higher range. So that's why we have zeros and then eights at the end of this list. It's the way that a piano is defined. So when we go to song, the song instead puts all these tones in order. And we have a couple of issues here. One, every sharp flat pair is a duplicate tone, so we don't need those. In fact, I don't want the letter F to appear before a number. Let's see here. Search for. Regex. There we go. Now I want to look for the letter F followed by a digit. 039. Okay. What we want to search for then, search for A through F, A through G, followed by F, followed by 0 through 9. So now that doesn't exist. If we take those 3 letters back in, search for A through G, followed by F, followed by 0 through 9. Those are the 3 matches. So when we define it, we're only defining the tone once by removing all of the flatted versions of the same tone. Then we put everything in order here. And everywhere that we have a sharp flat, I do want to be able to reference it by the same name. So all we do is we duplicate that entry, 2, 3, 3. So D sharp is the same as E flat. 4, 5, 6, 6. 7, 8, 8, 9. Oh, did that one have a duplicate that was already happy? Okay. So from here on out, I think I already duplicated the sharp flats correctly. So here's A sharp B flat is 14, sharp flat 17. So I think we're good from here on out. So all we're going to do, hey Javest, I'm doing good today. How are you doing? Playing with our music player. We're going to try to basically make a virtual machine that plays songs. Short stream today, or interrupted stream. So we're kind of playing. We're not really driving a particular task that hard. So right now we're just trying to fix a tonal offset, which is just an index problem, I think. So we're going to, oops. Oh, that's 13. We're actually really close already. So all we have to do is modify this keyboard macro we were already using. And we need to subtract 5, subtract 4. So instead of adding 13, we subtract 4. And there we go. That may fix our tone offset problem. So each note has an index in an array, but sometimes we want double notes, one for sharp, one for flat, that are the same. So that's what this enumeration is doing. It's telling us what index in the array is the actual frequency stored by name. Okay, so let's see if that fixed our offset for our notes. Doing really well, sitting in my new office in my new house. Congratulations! Should have a party. Nice housewarming party. Good. That means you've got your internet hooked up and your electricity hooked up at least. Good. Are you all out of your old place, or do you still have some moving to do? Sometimes it's easier to do the move in like 2 days. Move all the important stuff, get moved in, then go back and get the rest of the junk. But sometimes you're on a timeline. You don't always have time to do that. Okay, so here's middle C, C4. That sounded like the same C4. Oh. Yeah, we're back on track. Good. Part 1, done. One thing I want is to be able to debug the song, but not always. So down here, if dev debug song, there we go. We're just gonna make it so we can always turn this off or turn it on without plugging up my output. And there we go. No, nothing should log because we've not defined that symbol. No, all your stuff is out. Good. Going back to the old apartment to do some cleaning. Out of there for good. Nice. That always feels good. Moving out of the apartment into the house, into the home. Good, good. So we can set individual notes volumes and all that jazz. Cool. One thing we want to do is not load up the main menu. We want to load up the sandbox directly since we're playing with stuff. Very good, very good. Okay. Need to remember to just Control Q quit out of there. Okay. Journal. We fixed that. Phone being off in song was indeed an indexing error fixed now. So one of the main reasons we did this ordering is so I can now do things mathematically. I can say jump a full tone, jump a half, or jump a full step, jump a half step, jump, a third, jump a fifth. And we can do that mathematically if we want. We don't have to. Okay. We need different data sizes. So for example, pulse doesn't matter. Weight. We might need more than just this, which kind of reminds me of the replay functionality we have where we can scan different sized operations off. Is that something I want to do? So many options. Oh, here's another idea. Like, this is the problem. Once you go down this road, song, different tracks, song differentiate, overall volume, and individual note volumes, potentially. So we can have like a quiet, thing running in the background so we can balance the different pieces. Different tonal instruments. Right now we're just doing a hard sine wave. It's untreated, so it's not going to sound great for a while. Okay. I'm just going to steal that out of replay. It was too handy. It was in validate, or we did it in playback as well. So let's see what we've got here. We made scan. This is actually turning out to be kind of handy for binary data themes. Let's see what the other update. Scan 2. Log. and then the validate. So we have 4 different versions of scan in there. Three of them are identical. This one takes the playback index. Okay. And that's really the only difference, is that offset. Like, we change this to offset and this to offset, there's no difference. Yep. Okay. So we only really need one. So we get our opcode index, opcode, opcode. We need int 8t arg1 byte, 16 is from a 2-byte argument, and 32 if we want a 4-byte argument. So we're going to scan this thing. Instructions plus this and that. Okay. Hold on a second. I forgot something. Well, fetching a thing. I'm getting my chapstick. As the weather gets colder, my lips dry out, so fetching my chapstick. Be back soon. Just a moment. Shan't be long, I promise. Okay. Yeah, usually it just sits on my desk, but once in a while. Okay. I suspect that my opcodes are all going to change in a bit. but that's okay. Just gonna scan opcode index. Our opcode is that. Nothing to scan. Arg equals, so let's see here. Arg 1 byte. Except, let's see, what's 16 bits is 65,535 is the maximum value. Replay. Actually, let's see here. Add 4 bytes. Add 1 byte. I basically want something that's the opposite of this. Right? A value into m underscore instructions. Let's offset. Which is our new destination. From a source, which is the value, given the size of the value, and then an offset plus equals the size of that value. So we could say well, let's see here. Leave all this here in case we don't like what we're doing. Int offset equals 0. Right. Opcodes. Opcodes we can make. Opcodes. We can force those to be the right size, right? Let's see here. C plus enum class 1 byte. Okay, so we can do this. We can say this is a uint8t. And this is also uint8t. Now, this just automatically works. So we set volume. uint16t of 0.1 times 535. I mean, how many volume gradations do you need, right? This can be an 8. 255. Take a sine wave. I also get the waveform set that way? No. That would be in sound. Okay, set for weight, sine wave. Then we wait for, now we can have a multiple uint 16 of some duration. So we can wait 500 milliseconds. Then we're going to play a tone. Which in our case is also unit 8. It never goes above 255. It goes to like 108, so it's fine. Play a C4. Wait. Release. Wait 250. Play, wait, release. There we go. So C4, E, F, G. E, E, F, G. All right, let's just the delay. The delay is the part we need to change here. So we're just going through here and making everything a scan. So this duration, wait for scan for 2 bytes. Play needs a tone. Arg 2 byte. Okay. Release doesn't consume anymore. Here's a scan. This is volume. 255 gradations of volume seems fine to me. Therefore, scan arg 1 byte. Scan a byte. The waveform can be 1 byte. That's fine. Okay, let's try that. We may have changed memory layout by specifying enumeration sizes. So we'll do a clean. Yeah, I think a virtual machine that plays music might be kind of fun. when we shape those tones, I probably want like a piano, maybe an organ. I would not mind like a crystal bell or like a music box. I love the sounds of music boxes. Okay. It's not a class type. Okay. Oh. So it can't have a size of. Hmm. These values aren't variables. These are literals. They don't have an address. This is and well, you can't get a size of a literal. Well, you can get a size of a literal. Should just be that this piece, that address of value. Mem copy. We can use it, but we have to do a little bit more work around it. So let's go to song. Void right, 1 byte, 2 bytes, and 4 bytes. Okay. I need to turn those literals into parameters, basically. Then we have a thing we can do. I want this. Can I fit an entire octave or only half of it? 3, 4, 5, 6. C through F. How far is 120? Got a 116. So I got that far. G, A, okay. So there are 1, 2, oh, it is 12 tones. So 3, 4, 5, 6. This is the breaking point. Okay, so each octave is going to be 2 lines. 1, 2, 3, 4, 5. Oh, that's much more compact. Beautiful. That only fixes the first comma, but you know, mostly it's not that bad. Oops. Okay, and now and run it again. Boom, boom, boom. Oops, not that one. Whoa, 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 whoa. Back it up there, dude. There we go. There. Everything's nicely laid out. Takes up less space. Now, what was I doing? Oh, right one byte. Value and offset, maybe? Unit 32T offset. And ideally, we would load all this from a embedded buffer, actually, but you know, file or something. That's not what I said. I said copy that. 2 bytes. 4 bytes. 1632. What is going on here? Okay. Basically this. Offset plus size of the value. Then copy instructions at the offset, the address of the value, which now we have a value, and the size of the value. Which means we can do that. All right, write 1 byte. Most of these are write 1 bytes, so we'll just do this for a second. Then over here where we write 2 bytes are these ones. And set volume 0.05. We can have it get louder as we go, right? Before each play. Zero 6. Release, wait, play. Point 07. Point 8. Zero 0.9. Okay. Offset equals offset. We'll do that for every instruction. So offset equals offset. So I kind of want to do this the other way around. Offset and then value. Okay, that's going to be a little better because all of this will align better. Okay, so all these volume ones need to get fixed. Okay. Actually, all we have to do is search for set. Oops. Set volume. Search for offset. Search backwards. Paste. Done. Which means this rate is not useful anymore. It's fine. We just want to see if it works. Which it should. We should be able to play a song, or at least a tiny little scale here. It really wants me to do that. Okay, here's what we're doing then. Pound define set wave value. All we're gonna do is basically this offset equals, right, 1 byte uint 8t of the opcode, and then the same thing there. Uint 8t of our value. Set wave weight. Writing 2 bytes that value. So wait for 500 milliseconds. Set volume. You know what? Let's just simplify these. Wave weight volume. Value times 255, cast it down to a short thing. 0.05. Do I want to make these multi-line? It might be better. More readable anyways. Okay. Okay, so volume should be simple enough now. Play. Tone and time. Something like that. Okay, well, whatever. So play needs to pass to my opcode and my tone. Then it needs to wait. DT delta time. Then we release. Play C4 for 250 milliseconds. Wait, volume, play. Wait, 250.6, and play. So you can see with a little bit of abstractions, we can volume 0.7, 0.8, 0.9, and this is C4 D E F G. There we go. Let's see how it likes that. We can make those functions instead of macros if we want. Many options. We're just getting things started. Okay. Oops. There we go. All right, just waiting for the build to finish. We'll do a quick rebuild. Hey, Pat, how are you doing? Good to see you back. We knew about that unused variable. Doesn't affect what we're doing though. Okay, indoor sandbox, and it's not playing. Shoot. Shoot, shoot, shoot. Put my keyboard keys still play. I didn't break sound, just the song. Not too bad cooking bacon in the oven, waiting for my yeast to ferment. Bacon calzone night. Perfect. That sounds delicious. Tomorrow is donut day for me. That's what I'm looking forward to. Homemade glazed donuts, homemade maple bars. Some home squoze apple cider. All the carbs I have not been allowed to eat. It's gonna be great. Offset equals 0. Honestly, it looks like this should work to me. So did I break something? If we do that, and we unlock these once again. Weighed myself as well. Haven't gained a pound in 3 months since I've been making this stuff. Yep. 6'5". Jeez, you're a giant. Distributes well. Been this weight for a long time. Yep. Yeah. Not too long ago I outweighed you, but I was not 6'5", so I've spent the last 4 months undoing the damage, feeling better. Oh, I mean, you feel miserable while you're doing your workouts or whatever, but you just feel better. Huh. Now the old one isn't playing. So what did I do wrong? Yeah, step one, definitely stabilize the old weight as a kid. Oh, geez, okay. Didn't start doing it after high school, weirdly enough. Yeah, I was pretty much full height by 16. I was very skinny for 6 foot. So I was what was it, a junior in high school, 6 foot. I joined the wrestling team, and I weighed in at what 138 pounds, which on a 6 foot frame is a little on the skinny side. But there were really good wrestlers at 140, 145. So what I did was, instead of trying to starve myself and drop weight into a lighter category, I bulked up. And I put on 16 pounds in 3 months of muscle. So I actually wrestled 154, where nobody on our team actually wrestled. So I went, well, there's one other guy. He was no good, though. I know. I look at myself now, I'm like, geez, I was so skinny back then. But I did put on 16 pounds in 3 months in wrestling. Then I basically hovered around. It took me another couple of years to fill out the frame at all. But then, of course, the last, I guess 6 years. My professional experience has been working way too many hours, not enough time to exercise, or and then stress eating. So I put on quite a bit of weight over the last 6 years, which, as of what, maybe last week, I've undone 6 years of damage in 4 months of diet and exercise. So, but yeah, 6'5". You're not gonna lie, your picture on Discord does not show how tall you are. My gosh, you're huge. He's a giant. Pretty content with where I'm at now. Yeah, yeah, 6'5". I don't think your weight is too far off for that height. That's you're big. Yeah, eating bad as a kid. Yep, yep, yep. Yeah, you're probably fine at that weight. Me at 6 foot, at over a little bit over that weight, was not good for me. I could feel it. So that's good. As long as you're stable and you feel good, all good. But I do remember, like, one of my first jobs out of college, I actually had time to do running and stuff. I actually got in pretty decent cardio shape, and the better my cardio got, the faster my brain worked. Like it was wired for a while there, till I hurt myself. So why is the song not playing? What did I do to break it? Probably in here. We scan our opcode on next. We get our opcode. Let's debug our song. Oh, the other thing we need is a halt instruction. Actually, this could be important. Oh, this one has it though. All right, let's go through our debug and make file. -d debug song. Rebuild everything. Go check the bacon. Yep. That's not much of a song just yet, but we'll take a look at it. Just building tools right now. We're discovering the requirements for a virtual machine that plays songs. We have a light roadmap in our tasks today. Wait. Oh, wait a long freaking time. Holy smokes. That weight is huge. What is going on with my weight? That would be the problem. Sheesh. Oh. That's the problem with this one. This is reading 2 bytes off. This one, though. Weight should write the 2 byte value. Okay. So it never did a wait. Set waveform 1, set our volume, release. That is decidedly incorrect. Play. Play the tone. Then wait for some amount of time before releasing that tone. Ugh. This isn't actually the shape of instructions we want anyways, but alt way to play. So, hmm. We have to instruction. So we are going to have instruction index. Then the opcode index. I'm getting weird values. Yeah, so if these are opcodes, that is definitely not right. So we're not walking through this correctly. Memory copying in the destination. Instructions plus the instruction index. Number of bytes we're trying to save out. Then increment our instruction index by that same amount. Okay. Default. We should never get an opcode of whatever opcode index. Oh, and this is I'll bet that's the problem. Okay, I think I know what's going on then. We were stepping one more time than we needed. Okay. And now it dies. Play 304. Oh, it only needs 1 byte. Play does. Because we just need the tone index, which is a 1 byte value. Does that mean we were... Yeah, okay, so we were writing it as 1 byte and reading it as 2 bytes, so small difference makes a big difference. There we go. Finally, sheesh. We'll go 500, 500, and then we'll come back down. Getting louder all the way. So volume, etc. We'll play it all in reverse. This will be 10, 11, 12, 13, 14, G, F, E, D, C. Play weight, then volume, play weight. Okay. Try that. Ooh, we can set the waveform to triangle. I don't actually like the other waveforms. There we go. More or less working. Maybe we double our volume uptake, make it more obvious. Maybe replace this with like 125, so it's a little bit quicker. I like where this is going. I know this is not our final answer. 210. Okay. Okay, so we've done that. Our song needs beats per minute. Some better abstractions for instructions and argument sizes makes playing scales easier. I'm not going to count this C-major scale until we get BPM done. Not there yet. Okay. Song handles variable size args now. Okay. Quick restroom break. And then we'll start on the next thing, beats per minute. We'll be back. Okay. Beats per minute. All right. Ooh, whoa, whoa, whoa. Let's go back to journal. A couple things that might be easy are song transpose, which is basically a tonal offset index offset. Song speed offset. So for example, what I'm thinking right now is BPM is going to be something I can set within the song instruction set itself. So if we want to like speed up over time, or if there's a section of the song needs to be played at a faster tempo, we can do that. But then we can also just speed up the whole song. So all the beats per minute would then be sped up or slowed down given a speed offset. Now, BPM, weight is not MS, but rather a fraction of a beat. Okay. So, probably need a new opcode called set BPM (2 bytes milliseconds. 1 byte. Tone. Index. Volume is from 0 to 255 is fine. 1 byte. And this is 1 byte. Okay. So set BPM is opcode whatever. And beats per minute. I think I'm going to get away with an integer. Most songs probably aren't going to go faster than 255 beats per minute. Is that true? Is that true? Let's just start with 1 byte for now. 1 byte. And the units are implicit in the name, so I don't need to label that much. Then we actually need uint 8t underscore beats per minute. And then we're going to derive a value called milliseconds per beat. We will start with a default. Let's start with 100 beats per minute. Then we default milliseconds per beat. So if it's 100 beats per minute, it is 60 seconds. Why don't we just do this in seconds per beat? Seconds per beat. We need milliseconds. Right. Equals 60 seconds over 100. Well, yeah, there we go. 60 seconds over that number of beats per second, or beats per minute. Set BPM arg 1 byte. Okay, we should log it. Set BPM to something. Compute these things. Okay, that's setting the BPM. Probably most like this one. Set BPM. Let's start with 60 beats per minute. So it's 1 beat per second. BPM 120. We'll just double time it on the way down, right? And that shouldn't change anything because we're not actually using the BPM yet. So our weight still means milliseconds. But we should see it log out anyways. Okay. Somewhere in here. Set BPM 120. Perfect. Now we need to change what the word weight means. Weight. 2 bytes. Think about this. So we want fractions, so we want like a if your quarter note is your beat, then being able to play an eighth note is using a half, and then 16th note, all the way down to hemi, semi, demi quavers, which if I remember right is a 1/64th note. And then we also want to be able to play like full measures of silence, you know, four full beats. Do we need 64 beats of silence? It's 64 and 64. That means we can actually fit the weight into a 1 byte value. Fraction or multiple of a beat. I think we can do this with 1 byte and have reasonable. Or do we do it as a float? We could. We could just do that as a float. Why not? Float, fraction or multiple of a beat. Why restrict ourselves? We can write a float. And nobody will make fun of us for it. We can even do things like static, const, float, half, quarter, whole, half, quarter, double, quad, or four. A dotted quarter would basically be a 3/8. 3/8. EIGH 8. There's an H in there. 0.375 times a beat. Then we want the 1/8, which is 125. So a whole note is going to take 1 beat. A half note will take a half beat. 3/8, quarter, 1/8, blah, blah, blah. Okay. Let's get this right load up and running. It actually is not any different from anything else we've done. We still just have to copy it. So that when we scan during update, float arg float. So a weight is now a arg float. .3 f beats. We can then compute what is 0.3 f, the number of milliseconds, which is arg float, number of beats, which is some number of milliseconds, which is the number of beats. So arg float times m_seconds per beat. Is this is how long we wait. So we don't have to deal with milliseconds, we're dealing in seconds. So that's it. So we're changing weight to be in terms of beats, and then computing our frames, our delay seconds in that amount. So up here, set a weight 500. We're going to wait for song a double beat. Anything where there's a wait now, we don't write 2 bytes, we write a float. A float. Okay. Then we're going to call, if it's 1 beat per second, we want it on for 3/4 of a second, off for an eighth of a second, or let's see here. What else do we need? Maybe we need some more values here. Half, 3/4. Seven eighths, 5/8. 875. 5/8 would be 625. 3/5/7/8. Wherever this double is, I think we want actually half. Then where we have a 250, we want 3/8. Which will be I need a number. It's song 3/8. Anywhere there's this 1, 2, 5, we shall replace that with song 1/8. Okay, so at 60 beats per second, 60 beats per minute, we're gonna play for. We're gonna wait for half a second. Then we're gonna every half second play a tone and stop. Play a tone and stop. Play a tone and stop. Then we're gonna up our BPM, and we're gonna screen through it double time. Okay, try that out. It wants const expert. We're using 2 bytes of integers, so that also goes away. Okay, let's see how BPM is working. That sounded like BPM control to me. Oh, what? So yeah, that seems to work. Journal. Okay, transpose. Speed offset or multiplicative factor. Unsure. Okay, so transpose. Oh, okay. See, there are so many different ways we could do this. Like, if we want to run the song at double time. Transpose. Hmm. I don't remember now. How big do we make our instruction list? 256. Let's make it a little bigger for now. We can make that all dynamic later. I just want to make sure I have enough room. Okay, so here's so these two could have relative, so like adjust volume and adjust BPM versions of these opcodes. So that's one thing we could do. Another is that the volume is always multiplied by a song constant. Okay. He's a little early. He's dropping Ethan. Okay. All right, folks. I have got to get going. I've got a thing at 3. Apparently it's early, so I'm gonna sign off. And we'll pick this up. Depending how long this errand takes, I may hop back on the stream, or if it's late, then I might not. I'll let you know in the stream announcement once I've made my decision, once I get back, if I'm hopping back on or not. So if I see you this afternoon, evening, later, see you then. Otherwise, I'll see you tomorrow. Have a wonderful day, and goodbye.